Yes.
Okay.
Let's see. Okay. So, can you see my screen?
Yes, I see you.
Okay. So let's start. Okay. Hello. Good morning and good afternoon and good evening. And so welcome you to this World River and Delta System Source to Sink webinar series. Today is 2020, and it's just like a Shanghai in the Yangtze River, on the Yangtze River Delta, like New Orleans on the Mississippi River Delta. So he got his PhD actually also from US, University of Texas at Austin. And it's a co-program between the Austin and Tantau University. His research interesting is sedimentary and environment geology, also evolution of oil and gas, and also the coastal wetland. He has many international experience collaboration with colleagues from US, Sweden, Germany, UK, China, and Poland. And so his research now mainly focused on coastal lagoon of the Nile Delta and also Holocene climate change, and particularly the influence on the early agriculture from the Nile Delta. As we all know, Nile Delta like a culture cradle for the whole human culture and population is a very, very earlier stage. The human from whole history. We all know it's very early. It's very interesting how the climate and river interaction, over the Nile River Delta. So particularly one thing I will mention, very recently, he collaborating with the Eastern China Normal University and working on the Holocene climate change and human adaptation in the Nile River Delta. And today is actually the Chinese Lunar New Year. And I guess, we don't get many Chinese audience like always, like before. But so thank you for those who sacrifice their family time, still attended this webinar series. We will record this one and available later for you to watch. And okay, I think I mentioned enough. I think, thank you very much, Alaa from the Kafroshik and on the Nile Delta. So please go ahead, share your screen and put a presentation mode.
Sure, thank you.
Yeah, please click that one,
Okay. Thank you, Paul, for your nice words. And thank you all for coming over the webinar to attend my lecture. It's really my pleasure to participate with you and to share our experience for the international community. I'm very happy indeed for our collaboration with the East China Normal University, represented by State Key Laboratory for Estuarine and Coastal Research. And it's a long time cooperation since 2005, I believe. And we are happy for this collaboration with our university in Kafr Sheikh, a little above the middle of the Nile Delta. It's called KSU, Kafr Sheikh University. And our work has been funded by the Academy of Scientific Research and Technology from both countries, and also from the National Science Foundation in China, and from the Skillick laboratory in Shanghai. Yes, I'm actually also happy to meet my colleagues, Professor Zhong Ganshen, when I met him for the first time in Durham in the UK, in Durham University. And then we decided to face the challenges that our deltas facing in order to mitigate or to try to find solutions for the emergence and threats that our deltas face, doing research on that. Okay, this is the natural Nile Delta as it appears from a satellite image, and this is the Egyptian history time scale, because we also with my colleagues in East China Normal University, we working in the Neolithic sites in the Delta to trying to figure out the adaptation, human adaptations with the climate change in the Nile Delta region, and how they can move to sites for herding, for farming. That's what I'll show you later in this presentation. As you know, the Delta is a product of land and sea interactions. Different climate settings can act in different ways in the Delta, and marine dynamics can also make a coastal degradations on the deltas, and human adaptation can also adapt to these climatic changes. Human impact can make a big influence on the Nile Delta in terms of damming and degrading the waste, effluent, throwing effluents from the industry, agriculture, through the drains in the Nile Delta to the coastal lagoons. So we need to make a coastal conservations for our coastal lagoons for better life for Egyptians. I'm sure you're all familiar with the Egypt map. As you see here, the Nile River is the longest river in the world. It's about 4,000 miles, and it passes through 9 countries. In Egypt, it traverses over 1,000 miles and divides the country into 4 regions: Eastern Desert, Western Desert, and Sinai here in the northeast, and the Nile Delta with the Nile Valley. The sources of the Nile River coming from the heights, the mountain heights in Central Africa, and there's two sources of the Nile. There's the White Nile from the Lake Victoria in Uganda, is down here, and from Lake Tana in Ethiopia. So that's what we call the Blue Nile and the White Nile. They meet in Sudan and continues up north to the Mediterranean. Here is in Aswan, there is a big dam in Aswan city that we will see the impact of damming on the Nile Delta coasts. As you can see here, the Nile River flows south to north from the mountain heights in Central Africa. You can see 8,000 feet height, and with accumulation of sediments coming from the upstream down to the Aswan, to the Mediterranean, and sediments accumulate to form the delta. I'm going to focus in this presentations on a biography of the Nile Delta, as a brief biography of the Nile Delta, and I will let you have an overview of the challenges and disasters faced, and how as a government can take actions in order to adapt to help maintain a better environmental setting for the Nile Delta. The Nile Delta of Egypt is one of the earliest deltaic systems in the world. It was formed by sedimentary processes between the upper Miocene and the present, and it's built up by alluvium brought by the old former 7 active branches of the delta. This is the only 2 branches of the Nile Delta occur at the moment: Rosetta branch to the west, and the Damietta branch to the east. But there once several branches going in the Nile Delta when the Nile meets Cairo and it bifurcates 2 different branches in the Nile. This is a map. This map shows the location of ancient river branches, and the maximum transgression here, sea transgression, is outlined by Stanley and Warney. So these are the locations of the old ancient 7 branches, and the names of these, but they are now not existing. Only Rosetta and Damietta branches. Okay. The Nile Delta is about 22,000 square kilometers. It covers about 240 kilometers of coastal line at the Mediterranean from west to east. The climate is arid, with a high rate of evaporation and very low rainfall. And fish productivity is about 185,000 tons per year, but I'm sure it's now duplicated by the projects of big fish farm and Borolus area. The much amounts of fishing come out from this fish farm. About 40% of all Egyptian industry are located in the Nile Delta and threaten the Nile Delta by throwing effluents through the drains into coastal lagoons. The Aswan High Dam on the Nile Delta, built in 1960, it's built south of the country at Aswan city. By that time, when the Aswan Dam was constructed, the country was needed to high power for emerging industry, and it was also has the Swan Dam has much benefits for preventing flooding, controlling irrigations, and planting 3 crops a year instead of 1 crop, and also the farmland increased by that time by 30% before the dam, because it's controlling irrigation and several crops can be planted a year. But of course, dams come with this is the hydroelectric generator at Swan Dam, generating electricity for the emerging industry. That was the country was really in need at that time. But always the dams come with a negative effects. It's a pollution increase due to the no flooding and the very few sediments goes to the. I think by the dam today, almost no sediments go to the delta, which causes much erosion. This figure shows the amounts of sediments transported into the Nile before and after Aswan damming, and the data recorded from gauge stations at Rosetta Promontory. You can see here the months of flooding. You can easily recognize October, September, and August are the months of flooding. This is before damming, but after damming, there's almost no sediments. There are almost no sediments go to the Nile, which definitely cause erosions. Okay. Challenges faced, there are many challenges facing the Nile Delta. I will focus on the pollution and water quality deterioration, potential impact of sea level rise, and the consequence coastal erosions, seawater intrusion, sea level rise, and the consequence seawater intrusions in the Nile Delta aquifer, and what are the problems that come out of that. Land use changes and the change of land cover over the delta regions. This is our first project with EC-NEW in China. It was a spatial and temporal distribution of heavy metals on the Nile Delta coast, eco-environmental challenges after Swan Dam. In this small map, you can see the 3 major Nile Delta coasts called Mansala to the east, Porolus in the middle, and Itko at the west. This map shows the location, the 3 major lagoons with the sample location, core samples, and the location of the cities and the different kinds of drains pour into the lagoons, like Bahr al-Bakar anoxic drains. This is, by the way, this is the worst drain in the Nile Delta. And there's going to be, actually, there's a huge project will be carried out to treat the heavy metals contaminants close to in Manzala, and this project will be launched in June this year. I will tell about that later. We had core samples, vibro cores from Borollos, Mansala, and Itko. We did an extensive study over the 3 lakes, and in order to have an information of the distribution of the heavy metals along the coastal lagoons, and to know also to estimate the sedimentation rate, particularly after a Swan damming, using lead-210 and cesium-137 isotopes, and using the concentration CIC model, constant intensity concentration model for the lead-210 and the cesium-137, and to know how sedimentary processes can act after the damming. So this is a course from Mansala, course from Borollos, and course from Itko. The decline in the decline in the lead-210 in the upper section of Mansala and Itko is noticed here. You can see the decline in the lead-210. This actually indicates a sedimentation rate of about 0.27 centimeter a year. And using the cesium-137 spikes observed at the core depth of 9.5 centimeter of Borollos and 4.5 centimeter here of Itko, helped identify sedimentation rate of 0.22 centimeter a year. It's actually very a low sedimentation rate occur in the Nile Delta after a Swan Dam. So this low sedimentation rate is a consequence of the dramatic reduction in sediment load as a result of damming. By simple calculations, we can figure out that the upper 10 centimeters, or sometimes in some samples, it gives us an idea about the 10 to 15 centimeters. Anyway, so the upper 10 centimeter thick sediments deposited after the Aswan damming in 1964. So after damming, it's only 10 centimeter of deposits deposited of sediments deposited after Aswan damming. Knowing this amount and working on that for the heavy metals, the several heavy metals recognized in this study, this is the level of 10 centimeter deposition. You can realize that most of the heavy metals correspond well with the time of damming as they are increasing concentrations. All concentration of heavy metals increase upward, which correspond well with the time of damming about 10 centimeter sediments, ensuring large scale industrialization. Because as heavy metal increase, that's ensuring industrial and industry affluence after the Aswan damming and the Nile Delta. This is for Mansala and for Borollos and for Itko. So most of the studied, all of the studied lakes actually have heavy metal concentrations increased upward. So the distribution of heavy metals in Mansala, Borollos, and Itko, the 3 major lakes in the Nile Delta, goes like that. Mansala is bigger in the concentration or higher in the concentration than Itko, than Borollos, meaning that Mansala is the worst polluted lake in the region, in the Nile Delta region, and the Borollos is the least one. The controlling factor over this concentration of heavy minerals are wastewater type, either industrial or agriculture or sewage, because it varies. Mansala actually, in fact, there are a lot of industry concentrated around Mansala Lake and Port Said and Damita. So the type of wastewater reflects very much reflecting the kind of heavy metals and the concentration of heavy metals. Also distant to the drain outlet and the dispersal pattern, prevailing wind and currents, and finer are richer in heavy metal concentration than coarser fraction. calculating the contamination factor for 6 of the 6 cores implies that most enriched metals are lead, strontium, manganese, copper, zinc, and chromium. If you have a look at yes, here you can observe the most enriched metals and can calculate the contamination factor in this graph. If we look at this table, it's the heavy metals contrast. You can show the heavy metal contrast pre and post dam in Borealis Lagoon in particular. So for manganese and lead and cadmium, the values increase obviously after dam, because these values are before damming. These values are after damming. So comparing with the background values before dam. Another study, extensive study made in Manzala Lagoon of one of our students, master students, and you can see here the Manzala is the biggest. It's big actually, but now of course it's declined because of the land use and land cover. This is the Manzala, the morphology of the Manzala, where you can see the sand ridges over here. And the blue areas are islands. These are the drain canals and the outlet locations to the Mediterranean. Most of the lakes are open to the Mediterranean, were actually open and had proper exchange rate with the Mediterranean Sea, but now they receive a large amounts of industrial agriculture and domestic wastes. See the drains here. This is, I talked to you. I talked about that before. The Bahr al-Bakr. This is the worst drain in the Nile Delta. Because it extends from South Cairo to up to the Mansala, and it passes over mega cities where it can receive large amounts of waste from agriculture in the mega cities in the Delta and industrials, and to pour them in the Mansala, south of the Mansala Lake in this area. Okay, so this is the results of this study. The grain size analysis based on the United States Department of Agriculture shows that most of the studied samples are clay, loam, and loam, and mostly concentrated as clay loam here. And for the grain size distributions in terms of clay, silt, and sand, you can see here that the clay are concentrated near the drainage, the drain here, and the sand fraction or silted sand fractions are up north. This study was also aimed to evaluate the heavy minerals content that are concentrated in the northern side of the lake. We have observed epidot, magnetite, zircon, garnet, monazite, ilmenite, hornblende, and leucoxene. Okay, they are very much concentrated on the northern lake because of the beachy sediments are rich in the heavy minerals concentrations. Organic matter is very compatible with the grain size and concentrated along the drains here. This is a Bahr al-Bakr and its branch in this area, and very little organic matter are found up to the north. Extensive study has been done to figure out the amounts of heavy metals and the concentrations on the different parts of the lake. So the lead is concentrated here in the southeastern and south part of the lake because of the drains, and iron is very much distributed along the lake because iron is also present in the heavy minerals. So we encountered some high amounts of iron in the north and in the south and southeast, very close to the drains. Manganese, copper, and zinc. The most of the heavy metals are concentrated very near to the drains. Yes, magnetic susceptibility very much compatible also with the heavy metal concentrations. And for two cores studied, it shows that the core number 6 and core number 11, the magnetic susceptibility decreases with depth as the pollution is very minor as you go down in bottom sediments. Okay, pollution index for the heavy minerals studied, it clearly indicates that most of the values are above 1 that denote deteriorations and very much above the permissible values of World Health Organizations. So meaning that this Manzara Lake has been extensively polluted by heavy metals. This recommendation is just to tell you that the dredged sediments along the north coast of Manzala must be subjected to intensive examinations, intensive investigation to evaluate the heavy minerals contents and their economic value instead of just throw them away. So we have to take advantage of the heavy mineral concentration on northern coast of the lakes to evaluate their economic value. On the other hand, the dredged sediments from southern areas of the lakes that are polluted must not be being used for land reclamation before adequate remediations for heavy mineral contamination take place, because it's actually contaminated, so they must not be used for reclamation before remediation. Okay, this is a very recent study done by one of our PhD students in this year. It's still under review. He has made many sample coring and superficial bottom samples from the eastern side of Borulus and the middle side of Borulus, middle region of Borulus, and the western region of the Borulus. And his results clearly compatible with our earlier results for the recognized heavy metals in Borulus. And also, if you compare his results with the Itku, Manzala, Borulus, they are very compatible, very near to our earlier results of Borulus. And for example, see if you can have a look at the cadmium concentration in Borulus is okay, but for Manzala is very high amounts of cadmium. Some researchers, some earlier research reported the pancreatic cancers in the fishermen working in Manzala Lagoon because of the rich cadmium level in the blood. The cadmium blood serum level is high in the Manzala farmers. That's responsible for the pancreatic cancers in the farmers of Manzala Lagoon. So it's really highly polluted in Manzala. Comparing the Nile River, Nile Delta with the Yangtze Delta, and the two climatic differences. The Nile River is a dry climate, while the Yangtze is monsoon climate. So the climatic-driven systems in both deltas clearly govern the diffusion items, the diffusion or the heavy metal concentrations in both levels. In the Nile Delta, it's the same. There is a dam here called the Swan Dam, and in Yangtze, the Three Georges Dam, and the sources are the same for pollution. But in the Nile Delta, because of the Swan Dam, there's a weak runoff and no sediments, which causes the heavy metal sinking in the coastal lagoons, coupled with the wave erosion from the Mediterranean. But in contrast, in the Yangtze, because of the strong runoff. So the heavy metals diffuse out to the East China Sea and is a large sediment. So there's a completely different settings in terms of climate. Okay. Let's go illustrate, show you here the huge national project, which is going to be launched on June this year. This project is located here, very close to the Bahr al-Bakr, the worst drain in the Nile Delta, because it comes from the South Cairo to the passing through mega cities. This project with a budget of $1 billion, and it has a capacity to treat 5 million cubic meters of polluted water a day that will be available to reclaim and cultivate 400,000 acres and will be made available for agriculture-based industry, saving thousands of employment opportunities. This is really a huge, so the Egyptian government is really paying a great attention to for remediation of the heavy metal pollutants of the polluted water in this area for developing for a better life for Egyptians. So this is the actions taken by the Egyptian government, and it's going to be a huge national project indeed. This is a way to a research done to recycling coastal dredged sediments from the northern Nile Delta for heavy mineral exploitation. As I outlined before, that the northern coast is rich for heavy metals. So there is also this paper illustrates the dredging sites, 5 dredging sites here over the northern coast of the Nile Delta. A, M, E, H, and G. These are the dredging sites. In this figure, it shows the vibrocoral in B and C during the coring of the samples from the north coast. And here is the separation, the net for separating heavy minerals and light minerals. And this is for splitting the cores in the laboratory for evaluating the heavy mineral content in this coastal dredged sediments. And this bar charts shows the percentage, the average percentage of the economic heavy minerals and green silicates that are not economic. But the economic heavy minerals comparing to the non-economic, it shows an appreciable amount of economic heavy metal contents in this dredged sediments. I think this brought the mind of Egyptians and Egypt government to implement another huge projects at the coasts of Kafr Sheikh governorate here. This is another huge national project launched on the Kafr Sheikh north coast for getting the most use of black sands on the north coast. This project made by the agreement with the Ministry of Defense in Egypt and the Kafr Sheikh governorate and the Nuclear Material Authority. Now the Kafr Sheikh governorate, I think it's a lucky governorate because it has got the most of the funding from Egypt for this national project. Because the Kafr Sheikh actually is a big governorate. It extends from the middle of the Nile Delta up to the north. It's a coastal governorate that has a lot of projects running over their lands. It's absorbing this is actually extracting 45 radioactive elements from the black sands. And the survey done by the Nuclear Material Authority proved there are 11 sites on the Egyptian north coast extending for about 400 kilometers long. As you all know that the black sands are sources of many economic minerals. This is the area of the northern coast of Kafr Sheikh Governorate, the Prolus Lake, and this shows the cluster, heavy mineral clusters on the northern coast. And above that is going to be a high school for mining, is already established at Baltim city. Baltim is around here. All this coast of the Kafr Sheikh north coast. So this school of mining at Baltim city on the site with a total area of 11,000 square meters. I think this will comes out with a new opportunities for employment. These are pictures from the site. We see the black sands here, and they are digging and dredging sediments, dredging black sands for the project. Now let's go to have an idea about the impact of sea level rise and the coastal erosion. This is a recent sea level curve made by Frehi and others to 2020. It shows the relative of sea level rise estimated from annual tide gauge records at Alexandria here and Rosetta with different rates of sea level rise, 4.1 here, and Rosetta Promontory 1.8 millimeter a year at Alexandria city. So let's have a look at the impact of sea level rise. You can easily recognize here that the amount of erosions from 19, these are satellite images. It shows the amount of erosion from 1945 to 2015 at the Rosetta Promontory and at Damietta Promontory. This is a simple topography of the Nile Delta in its present form with a total area of 22,000 square kilometers. What would happen if the sea level rise? I think this is an elevation map, a topographic elevation map of the Nile Delta. It classifies the delta into 5 zones. The white line here bordering the natural delta. So the 5 zones actually this threatened, actually situated, this area blue line is actually situated topographically below sea level. It constitutes about 18% of the total area of the Nile Delta. And the yellow zone is about 28%, green is about 15%, and this is Kafr Sheikh. And the red zone is about 24%, and the black 15%. So you can figure out here the elevations above sea level for each zone. So data from ODA 2020, and in a scenario if the sea level rise by a maximum of 1 meter, what would happen? The yellow area, the yellow line here outlines the area threatens if the sea level rise above 1 meter, because all of these would be actually threatened and submerged by the sea level. This will constitute about 25% this threatened area, and if you add another 8% made up of cities and villages and roads in this threatened area, it will end up with a 33%, meaning that one third of the delta might be submerged by seawater if this scenario happens. Sea level rise will in turn will lead to seawater intrusion in the Nile Delta aquifer. This is a big Nile Delta aquifer called the Mid-Ghamr aquifer from the Pleistocene sediments. Here, Saif al-Nasr and Sharif 2014, they put 2 scenarios for sea level rise. If the one scenario of the sea level rise seawater intrusion under the conditions of 0.5 seawater level rise. And the seawater intrusions under the condition of 1 meter seawater level rise. So the first scenario will have scenarios 1, 2, and 3 with different pumping fresh water from the aquifer. So this is the seawater zone mixing. This is the seawater zone, the red, and the sky blue is a mixing zone, and the blue is a freshwater zone. So what would happen if the seawater level rise in these scenarios with different pumping amounts from the freshwater zone? So for scenario 1, it doesn't affect it because it's the same as base scenario. For level 2, of course, the seawater intrusions grow at the expense of fresh water when you pump, and the seawater grow at the expense of pumping fresh water. And this is scenario 3 for 0.5 meter rise. For 1 meter rise, things gets worse because the seawater intruded in lands for pumping 1.15 billion cubic meters a year. For pumping 2.3 billions, it gets more worse. And for the 6th scenario, this what happened when the seawater level rise 1 meter with a pumping of 4.6 cubic billion fresh water a year. So how would we adapt to that? The importance of changing cropping patterns in the Nile Delta through cultivating salt-tolerant crops that will be can solve the part of the problem. Creating wetlands in salinized low-lying areas. It would act as a natural defense against the sea level invasion. Sea level invasion. The importance of developing integrated zone coastal management for all coastal cities act as a natural coastal protection measures, such as sand dunes, sea walls, protection of coastal highway. Yeah, here are, of course, these are the wetlands that might act as a natural defensive against sea level. And there are 13 coastal projects running on the Nile Delta, already running on the Nile Delta. 7 coastal conservation projects at Alexandria here. 1, 2, 3, 4, 5, 6, 7 here, and Alexandria and Abu Qir, and Miami Coast, Mandara, Muntaza, Stanley Coast, and 4 along the coastal line between Rosetta and Damietta. 4 coastal conservation projects are running here, and 2 along the eastern Delta coast at Port Said. So this is a kind of protection constructions carried out by Shore Protection Authority, like constructed parallel bars, the sea walls on the promontory, on the estuarine part, sea walls and barriers. As you can see here, this is one of the parallel constructed bars on the western coast here. On the western coast, this is the Rosetta promontory, and on the eastern wall, this kind of barriers and concrete constructions. This is the western sea wall. The natural chain of coastal sand dunes act also as a defensive policy for the invasion of seas. This is, you can see the Mediterranean here. This is the sand dunes, and also there's a coastal highway running between Alexandria in the west to the Port Said at the east. This is actually the highway needs maintenance. So the occurrence of highway also may act as a defensive policy. This is a natural sand dunes, and this kind of coastal protection works. Sand dunes at the west side of the Rosetta regions. Muhammad Ali seawall protected cultivated lowlands but in the Abu Qir area, this is the Abu Qir Bay, very close to Alexandria, and it has been protected by, it's protected by Muhammad Ali seawall because this bay is a lowland area, 1.5, 2.5 meter below sea level. Okay, also maintaining the regular maintenance of resorts will gain land for the resort and will act as against attack before the construction or protection work. This image is before the construction. This kind of Ras El Bar resorts in very close to the Mita branch, the Mita promontory, and this after construction or protection works, actually it gained lands after the sea, the detached breakwater moved further to the sea. Okay, let's have a look at the morphology of the three Nile Delta lakes and the changing of land cover, surface area, vegetation, and water body. And we'll see after that the urbanization, extensive urbanization affecting the Nile Delta area. So for the morphology of the Manzala Lagoon, this is the current area. It has been declined much for over 50 years. We will see later. This is the area. This is the vegetation. So it declined to 44% from its original area. Vegetations increased and water body declines, as you see here. And the same for Borollos and for Itko. Itko now it's only 58 square kilometers because it has been really suffered from high land cover changes and high reclamation area. So if you look at the area over the original size of the Manzala area, 1,500 square meters, over years, I think over 50 years, has been declined much over the last 50 years. So this is the area 2019, and this is the area 1972. You can realize how much declining, how much shrinkage in the area of Manzala lagoons. The same in Borollos, area declination area, shrinkage area, and also for Itko, it has been suffered much shrinkage of the natural Itko lake. Consequently, the water body declines. The water body is only 431. Before 1972, it was almost 1,000, and this is for Borollos water body. For Itko, from 1972 to 2019. These are done by satellite images over years. So this slide shows the urban expansion and change in the major land cover classes from 1972 to 2017. The pie chart here illustrates the proportion occupied by each land cover class. We have several land cover classes here, like old cultivated land, new cultivated land, urban, the bare virgin land, aquatic vegetations, water bodies. This expressed in thousands of square kilometers and also as percentage in the pie shape. So the pie shape here shows the percentage, shows the amount in thousands of square kilometers and percentage. So this is in 1972. There was almost no urban expansion and no new cultivated land. But over time, so you can see here the expansion is urban expansion is growing, and the new cultivated land is also growing at the expense of bare virgin land and the old cultivated land. Okay, 1992, much more urban expansion. 2003 and 2011 sees the urban expansions and the new cultivated land. And you can realize on the topography of the Nile Delta here as well, 2017. Okay, so this urban expansion really influences the Nile Delta topography. Adaptation to the land use change, there must be a gradual decrease in the current cultivating area to obtain a higher level of crop management and switching cropping activities to aquaculture. As I told you before, there is a big aquaculture farm in Borollos. Egyptian government is also implementing a project called the Salam Canal. Salam Canal to reuse agricultural drainage water to create new communities along the canal and to rechart Egypt's population map and to also bringing water to the out to the desert of Sinai for development for agriculturing and for the developing plans in the northern Sinai desert. So this is actually the Salam Canal is here. So phase one is to cultivate 220,000 Fidan or acres in English. And phase two is planned to cultivate 400,000 acres. This Salam Canal, it goes below the Suez Canal and extends to the east, to the northern side of Sinai. Here's a close-up view of the canal. This is a Salam Canal below goes below the Suez Canal and goes to the northern side of Sinai. This canal will save 2 billion cubic meters of Nile water plus an additional 2 billion cubic meters of reused drainage and other waste material will be made available for developing plants and agriculture in the northern Sinai, in the northern side of Sinai. Okay, this is actually a big, huge project done by the Egyptian government. Okay, I will finish in the coming two slides. Change and human adaptation. Let's have a. This is a recent project with East China Normal University in Shanghai. It's about the Holocene climate change in the Nile Delta and its influence on the human adaptations and the early Egyptian civilizations. So in this project, we selected, so far, we selected the two sites from the west, two Neolithic sites from the west of the Nile Delta and from the east. It's called Sais and Kom Khilgan. What we did here is we go to the Neolithic sites and dig a trench nearby the sites and collecting samples, starting from the soil horizons and passing over the several cultural layers until we hit the sandy layer of turtleback. It's called in Arabic Gezira sand. So we take high resolution samples from the cultural layers. We bring them, take them to the lab for analysis. We aim to examine the pollen and non-pollen spores for having an idea about the early farming and what the Egyptians, all the Egyptians cultivating during history. And we also calculate the dating, carbon-14 dating for the several cultural layers along with the pollen and the non-pollen spores. We have already published a paper 2020 on the Holocene climate change and its influence on early agriculture in the Nile Delta. And there is one under review. Also, it talks about the climatically driven early agricultural origins and development in the Nile Delta. So the both based on the climate change. This figure show you the pollen, non-pollen spores, and it clearly it reflects the earliest farming started about 700 calibrated year before present, as indicated by the abrupt appearance of cereal. See the poacia pollen. This phase is suddenly appeared in age history of 6,700 years before present, as indicated by the abrupt appearance of this poacia of cereal. So during the time of climate warming, because before that there was an era of flooding in the area, and after that there was a period of climate that the Egyptians domesticated the cereal farming. So this is really a huge, this is a very big findings and achievement we have done so far. And research is still going on, and we much hope for a better achievements for our Nile Delta. So we are really optimistic and looking for any opportunity for a better development of the Nile Delta, even if it's only one smiling face. We are really optimistic. Thank you very much for your attention.
Thank you, Alaa. That's a very, very interesting talk. So, for the audience, if you have a question, you can just unmute yourself. Just go ahead to ask. So, I have a quick question. Alaa, you mentioned the dredging. The dredging is mainly for mineral, try to get the mineral, harvesting the mineral, heavy mineral. So this is a kind of very interesting. It's very different from the sand dredging, like over the Mekong Delta, Irrawaddy, the Indus, and even many other world major river deltas. They are mainly for remove the sand like resources for construction, and that's totally changed the budget of the river sediment. But over the Nile looks like after they harvested the mineral, where the sand they dump to, they leave the sand, they left the sand on the coast.
Yeah, definitely. They bump it down to the same place. We just take the very low amounts of heavy metals, economic heavy metals. As you see, it's we don't make any change of the sand because this is very much protecting the coast. So we bump the sand back. We bump the sand back to the coast after investigating the heavy metal, evaluating heavy metal and extracting the heavy minerals. Heavy minerals content. Okay.
That's a very interesting perspective, because even we don't you don't really move with the sand away. Somehow still disturb the seaflow, maybe increase the resuspension, and also increase the longshore transport away. I mean, that we need more study about this topic. That's very interesting.
Yes, definitely. We don't move the sands away, because that meaning you are obstructing the coastal. You are making the coastline very much vulnerable.
Yes,
we don't throw. This project aimed to extract the economic heavy minerals from the sand diffraction, and we keep the raw materials as it is. Okay. It's actually a huge project. It's gonna be launched soon.
I will talk with you more as we talk about. I always want to compare the Nile longshore transport with Yangtze and even the Mekong Delta, put them together. So let's talk about more about this. Okay, let's from our audience. Bill, you want to ask directly? Bill, you want to speak?
Sure. Excellent presentation. Could you speculate on the impact of the Grand Ethiopian Dam being filled on the Delta and along the Nile? Thank you.
Yes, the Ethiopian dams, would affect, of course, and we will have might have a shortage of water. That's why we look for other alternative sources of fresh water, like remediating the drainage water for what you call it, desalinize the water, and we also make water from other branches of the Nile out to the desert for developing. But it would definitely affect. We also look for the underground water for developing plants, but it would affect the area, of course.
Is Michael?
Yeah. So two things. One is the diversion of water to the North Sinai. How significant a fraction of the water is that? Is that going to make the seawater, the saline water intrusion worse because you have less fresh water coming down? And can you speak any amount about the land subsidence in the delta?
Okay. Yes, diverting the water out to the Sinai. It's not only depending on the fresh water from the Nile, but also contributing the water, the remediation of the drainage water, which will save billions of cubic meters of water available for irrigation and development in Sinai. Yeah, subsidence is Stanley reported the subsidence rates in the Nile Delta. I don't have a figure now, but there is a continuation in subsidence.
Right. I think I've also more recently seen some INSAR data as well, suggesting that there's a significant amount of subsidence that's going to make the sea level rise problem worse.
Yeah, of course, the subsidence will make a chance for sea level to go over the land, to go inland. So subsidence is a problem, of course, definitely. Particularly because no sediments, almost no sediments goes to the Nile Delta. Yeah.
Okay, cool. Song Bing from Nanjing, please go ahead.
Dear Professor, thanks for your wonderful presentation. I have a small problem about your presentation. Why you using the pollen of a person bigger than 35 millimeter can using one kind of proxy of earlier farming in Nile Delta? Because in China, generally we use the proxy, which should be bigger than 38 or 40 millimeters.
You mean bigger than 35 micron? You mean the pollen, because the pollen, yeah, the pollen bigger than 35 microns are the kind domesticated, because we ignore the pollen, the cereal, the Boesia less than 35, because they are distributing all over the area, and the sudden appearance of the Boesia more than 35 micron indicate the starting of farming at 6,700 years before present. And still, this work is still. I mean, we are continuing research in this work for the next years.
Thank you.
I hope I did I answer your questions?
Sorry, I cannot fully understand your answer. Maybe I can send you an email to.
Yeah, definitely. You're welcome.
Okay, thank you.
Thank you.
Any other question? So Alaa, we know the S1 High Dam is 1960. From now is already 60 years. So this is much earlier than the Three Gorge Dam. Three Gorge Dam is only about 17 years. So this is much ahead. we should see the impact of particularly on the Siberian Delta and the water portion of the Delta. Is any study show any sediment erosion and the water of the Delta? Because you see the shoreline, Alexandria, shoreline is severely erosion retreat. But how about the underwater portion of the Delta?
The underwater,
Is that study?
yeah, there must be, of course, there must be some research going underwater, but I have no data for the moment. But definitely, because as you said, the Swan Dam has been constructed more than 60 years from today.
Yeah.
So you can realize how impact has caused because of the no flooding, no sediments, almost no sediments go to the Nile Delta.
That's the interesting. Of course,
and you know the dry climate, the rate of the high evaporation rate would also contribute to this problem. Okay.
Yeah. There are definitely many other environmental challenges like subsidence, like saltwater intrusion, of course, sea level you mentioned. So that will be very interesting, place to work or compare with other world major delta systems like the Mekong, like the Indus, like the Ganges, and even Yangtze. So, okay, let's see if any other question. If no other question, maybe we can stop here.
But I'm seeing this as I think this time is a new era for development, because the Egyptian government is really paying a great attention for trying to solve and adapt to these images and to this, in terms of huge projects and looking for other sources of water, such as groundwater, water desalinations. Many projects are really put ahead for the Egyptian cabinet.
That's wonderful. Okay, let's keep in or more talk, about the field collaboration and particularly after the pandemic, we should resume our exchange, our dialogue. Okay, so once again next week, Neil Bear and Hans Paul, to talk Wednesday and Friday. Okay, thank you very much.
Thank you.
For you participate. Alaa, thank you very, very much. And it is great talk. And,
thank you, Paul. Thank you, Paul, for
so let's keep in our talk. Okay, that's we have a lot of to do. And
yeah, sure. Thank you, and thank you for the audience. So thanks for bringing me here over the webinar.